Okay, let's review completing the square. So let's say we have an equation in factored form. Say they gave us f of x equals x plus 3 times x plus 7. And it says get this in vertex form. Well, in order to get this in vertex form, we first have to get it into standard form. So we have to multiply it out. Now, I think I've shown you guys in class 2 different ways to do this. You can either, or I've shown you 3 ways. You can either do FOIL, which F-O-I-L. It is first, outside, inside, last. Well, first would be your x and your x. Right? So x squared. Outside would be your x and your 7. So plus 7x. Inside would be your 3 and your x. So plus 3x. And last would be your 3 and your 7. So 3 times 7 is 21. So plus 21. Now look at this. You've got 2 like terms, so we're going to add these. X squared plus 10x plus 21. So that's multiplied out, okay? Another way to do this is you can remember, this might be a shortcut. Now do FOIL if the shortcut doesn't make sense to you, but your first term is always going to be the x times x, which is x squared. Now your second term is going to be your 3 and your 7 added together. So it's a positive 3 and a positive 7, which is a 10x. And then your last term is going to be your 3 and 7 multiplied, so plus 21. So whatever numbers are here and here, your middle term is going to be those added in front of your variable, and your third term is going to be just those 2 numbers multiplied, and it's a constant. And that gives you your standard form. Now, yet another way to do this, a third way, is the box method. You can make a box. You can put x, let's see, x, 3, x, 7, and multiply these. X times x, x squared. 7 times x, 7x. 3 times x, 3x. 7 times 3, 21. What does that become? Well, x squared, and then 7x plus 3x is 10x plus 21. Alright, so those are 3 ways to multiply 2 binomials. That's what binomial means. It's 2 terms. And they multiply to be a trinomial, which is 3 terms. Okay, so in the previous slide, we took the equation from factored form, we multiplied it out, and we got it into standard form. This is standard form. Now, we want to get it into vertex form, and in order to get it into vertex form, we have to complete the square. And completing the square will make more sense if you remember that your middle term, when you multiply things out, is always the second terms in your 2 binomials added, and your third term is then multiplied. So, and since we want to have a square, they're going to be the same number. So we want this to be, we're going to have x squared plus 10x. We have to add something in order to make this into a perfect square. And then we have to subtract that same thing. And then, so I'm going to put 21 off to the side. So I want something that I'm going to add to make this a perfect square. Well, whatever it is that goes right here is going to have to add to itself to be this. So if I divide this by 2, I get 5, right? Well, this is x plus 5 times x plus 5, right? So added, 5 plus 5 is 10. What's 5 times 5? Well, it's 25. So I'm going to add 25. I'm going to subtract 25, right? So these three terms right here are what make this perfect square. Now I had to subtract a 25 because if I just add a 25, then I'm completely changing the value of this entire equation. So if I also subtract 25, I'm adding 0 to this equation. So I'm not changing the value of the equation. So I take the first three terms, I make it into the square, then I still have this negative 25 plus 21, so I have a minus 4. Now, this is now, you can say y equals or f of x equals, whichever you like. This is our vertex form. And it's called vertex form because it gives us our vertex. If you remember, you have a, which we don't have an a value right now, x minus h squared plus k, where h comma k is our vertex. So if h comma k is our vertex, notice that this is x minus h. That means our h value is going to be the opposite sign of our equation. So what is our vertex of this? Our vertex is a negative 5, negative 4. The k value stays the same sign. The h value is the opposite sign. That is our vertex. And also remember axis of symmetry. Axis of symmetry is always x equals h. It's that line. So this axis of symmetry is x equals negative 5. Okay, now sometimes when you're wanting to complete the square, you have a lead coefficient. That's this number right here. That's the coefficient of x squared that is not a 1. So then in this case, it's a negative 2. So we want to complete the square, but we need to get a lead coefficient of a positive 1. So I'm going to factor out a negative 2 from my first two terms. So I have this x squared, and then if I factor out a negative 2 from a negative 4, I get a positive 2x. Now, I'm going to just leave the 6 out here because I don't need it for completing the square. In fact, it's just going to be in the way. So I'm going to just push it off to the side. Now, in order to complete the square, I need something squared that's going to end up being what this is, right? Plus whatever number. So, if you remember when multiplying things out, the numbers, the constants, are going to add to be the middle coefficient, and they're going to multiply to be our third, our c, right? So, okay, I still have this negative 2 out here. So I'm going to take this 2, and I'm going to divide it by 2, because it's a squared, which means this number has to be added to itself to be a positive 2. So if I divide 2 by 2, I get 1. 1 plus 1 is 2, right? So now, whatever number is our third term is going to be this number squared, because 1 plus 1 is 2, but 1 times 1 is 1. So I'm going to add 1, and then I'm also going to subtract 1. And the reason I do that is because if I just add something to this equation, then I'm completely changing the value of this entire equation. But if I add it and then also subtract it, I'm adding 0. So I'm not changing the value of the equation. So I use these three terms to make my square. Okay, and then now I have this negative 1 out here, and I want to take it out of the parentheses. And in order to do that, I have to multiply it by this negative 2 that's outside the parentheses. So a negative 2 times a negative 1 gives me a positive 2 plus the 6 that's out here. So I have negative 2 x plus 1 squared plus 8. And that is my completed square.